This brief tutorial will cover how to utilize targeting workflows to add constraints to your data in Dot3D before optimization, even when you don't actually have targets in your scene. While it is recommended that you utilize April tag targets or at least checkerboard targets for these workflows whenever possible, you can still take advantage of these procedures even when you don't have targets, as we'll show you here today. So the first step here is going to be capturing a quick sample scan for demonstration purposes only of a section of this tiled floor. Such a small scan would normally not require any added targeting constraints and is very accurate in its own right, but we're going to utilize this as just a quick rapid example of what you may want to apply across larger area scans. So we'll finish up that scan and take a look here at our unoptimized data set. Before we move forward to optimization, we're going to implement targeting constraints via the Edit Targets tab. In this case, we're going to apply a simple scale bar measurement, a tape measurement taken across the floor for demonstration purposes. In most targeting scenarios, you'll be utilizing multiple scale bar measurements or 3 or more known XYZ coordinates for hard targeting workflows. And the same general procedure shown here also applies to all of those more typical targeting scenarios. So seeing as we don't have any targets in our scene this time, we want to check Use Checkerboard Targets or Other Custom Targets and press Next. And Dot3D will let us know that it could not detect enough targets, which is expected in this scenario, so we click Add Custom Targets. On this screen, we're going to input the target information that we have available to us. In this case, 2 simple scale targets, so with no known coordinates. I'll create one called 1 and another called 2. And the distance between those 2 targets from 1 to 2 has been measured as exactly 45 inches, and I press Create. If you had more scale bar measurements to add or multiple targets with known coordinates, that would all be inputted at this stage as well. In this case, it's just the one, so we're going to go ahead and press Next. And then select View/Change Associations, as we do need to actually create these associations in this case. I will then see frames available to select my custom targets. So I'll select one that has the point that I've measured to and from. This intersection point between the tiles, I'm going to designate as target number 1. Then I can go back and select whichever frame has the other end of my measurement most clearly present. Select, use my zoom window, and then set that as target number 2. And then press Next. Now that my associations have been set, I just need to press Next, close and optimize, and you'll see that the Use Targeting box has been checked automatically and set in this case to scale bar targeting, and I optimize my scene with those constraints implemented. So before we finish up here, let's quickly verify that measurement here in Dot3D. So I will go to Measure Distance, then tap or click and hold on the point that we utilized in our scale bar workflow, and then do the same at the other end of that scale bar measurement as precisely as possible using your zoom window up top. And there you have it, exactly 45 inches in the optimized data set. As you can imagine, for larger scale scans with potential drift, this can be extremely helpful to tie down very precise measurements, ideally across your X, Y, and Z axis using scale bar targeting on a scan of a room, or utilizing known target coordinates, so X, Y, Z for 3+ points, whenever such survey control information is available to you. For more information, please visit dotproduct3d.com.